You fire a projectile at an angle of 20 degrees with a speed of 30 meters per second. It's fired from the ground and lands on the ground some distance away. How far away does it land? We've drawn our picture. Here's our projectile. The hypotenuse is the 30 meters per second of this right triangle here. And the velocity in the x direction is here in red. That's the adjacent side. Velocity in the y at the start of the problem, the initial velocity, is in green. That's going to be the opposite side of my triangle. Pulling some numbers out of my triangle, everything to the right or in the x direction is going to be in red. Everything up and down is going to be here in green. So in the x direction, what we are trying to find is how far this projectile is going to go. So that is my question mark. I don't know the velocity in the x direction yet. I'll solve for that in just a moment. In the y direction, I know my displacement is 0 because it lands on the ground and it started on the ground, so the height distance difference from start to finish is nothing. The initial velocity, I'm not sure what that is, but I'm going to calculate it in just a moment. The acceleration is negative 9.8 meters per second squared. We're going to do a little bit of right triangle geometry to solve for the velocity in the x and the velocity in the y. The velocity in the x is the adjacent side, so I'm going to use cosine. The velocity in the x is going to be the cosine of my angle, which is 20 degrees, multiplied by the hypotenuse of the triangle, which is 30 meters per second. When I plug that into my calculator, I'm going to get 28.2 meters per second for my velocity in the x. So that's how much velocity the projectile has toward the right at the beginning of the problem. And because the velocity in the x direction never changes, that's the velocity it has toward the right until the projectile lands. In the y direction, we're going to do the exact same thing. We're just going to use sine instead of cosine. So when I do that, the initial velocity in the y equals the sine of 20 degrees times 30 meters per second. And when I plug that into my calculator, I get 10.3 meters per second. I'm going to plug that here into my initial velocity, 10.3 meters per second. So that's how much velocity the projectile has going up toward the sky at the very beginning of the problem. If I want to solve for displacement in the x direction, we only have one equation to use for that. Because it's constant velocity motion in the x direction, displacement equals velocity multiplied by time. The issue is I don't know the time. I know the velocity, I know it's 28.2, but I don't know the time, so I can't solve yet. So what we're going to do is we're going to solve for the time in the y direction and then use that in the x to solve for the thing we ultimately want. So in the y direction, I'm going to pick the equation without vf in it. That's d equals v naught t plus 1/2 a t squared. I'm actually going to plug in the 0 for d because that's going to simplify my math. I don't have to use the quadratic formula on this problem because 0 equals v naught t plus 1/2 a t squared. And now what I'm able to do is divide the whole thing, every term, the 0, the v naught t, and the 1/2 a t squared. I'm going to divide each of those by time. And when I do that, I'm going to use the red just to show what cancels. 0 divided by t just remains 0. So that stays the same. The v naught t, the t's are going to cancel. And the t squared divided by t is going to cancel the squared. So that's going to make my equation is 0 equals v naught plus 1/2 a t. I'm now going to solve for time. By rearranging a little bit, I'm going to subtract the v naught over. So negative v naught equals 1/2 at. I'm going to get rid of the half by multiplying by 2. So that's going to give me negative 2 v naught. And I'm going to divide the a over to the left side. And that gets me t all by itself. I can plug my numbers in. Negative 2 multiplied by v naught is 10.3 meters per second divided by negative 9.8. meters per second squared. The negatives are going to cancel, so the negative in the top and the negative in the bottom cancel each other out, making my answer positive, which is good because we don't want negative time. Positive time is what we're looking for. And that's going to get me a time of 2.1 seconds. So now I'm going to take my 2.1 seconds and I can use that in the x direction in order to solve for the displacement in the x. We already know displacement in the x is velocity multiplied by time. So displacement in the x equals 28.2 meters per second multiplied by 2.1 seconds. And when I plug into my calculator, what I find is 59.2 meters is the distance this projectile goes in the x direction till it lands.